let's start here with how the whole periodic table really came about. Maybe.
Russian chemistry professor named Mendeleev was writing a textbook for his students when he began to wonder how he could best explain to them the 63 elements that were known at the time.
Get that? 63 elements. How many do we have today? We have over 100. Only 92 of them are real, but at that time there was only 63. You guys say, well, why not make them alphabetical? That would be nice. But he had a different idea.
To help formulate his thoughts, he constructed a card for each element. On each card, he wrote the name of the element, its atomic weight, its chemical properties, and its similarities to other elements. He then laid the cards out like a game of solitaire and began arranging them over and over, searching for patterns. Then came the moment of discovery. Before him was something extraordinary. The elements fell into 7 vertical groupings. Each periodic grouping had members that resembled one another, both chemically and physically.
Okay. Before then, some people had put them alphabetical. Some people had put them by simply, let's go 10 across and keep following them in. He said, you know what? These chemicals here all kind of act the same. They react the same. These chemicals over here all react the same as each other. So he started fitting them in so they go by atomic number across in rows, but then the reason it's that wide and has that many columns has to do with how they react.
Mendeleev had discovered the periodic table of the elements, a map showing how all the elements related to one another. A map so precise that Mendeleev believed he could also use it to predict the existence and properties of 3 elements no one had yet discovered. One.
So he had a gap here. No one ever found an atom with 31 protons or an atom with 32 protons. So he just left a spot for them. He says, they're out there somewhere. We just haven't found them yet. And he says, I think they'll react like aluminum and boron and indium. I think they belong right here. I'll leave a gap for them. Well, we have discovered them.
He said. One like aluminum and one like silicon. Eventually, the elements were discovered, and Mendeleev was proven right.
That's a typo. There we go. That's correct. Where did his voice go? I think we may have
In 1869, a Russian chemistry professor named Mendeleev was writing a textbook for his students when he began to wonder how he could best explain to them.
Welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about electronic configuration. What you'll learn in this screencast is how to label a periodic table for electronic configurations. You'll also learn how to find the electronic configuration for any element. Now, there are a couple of things you're going to need. You're going to need a periodic table, and you're going to need some coloring pens or pencils. Let's go ahead and get started. Well, here we have our periodic table, and the first thing we want to do is we want to label down the 4 blocks of the periodic table.
All right, why doesn't yours look like his? Who has the real one? You guys do. You got the real one. This is the jinky one that they always show you in the back of the book. Where do these 2 bottom rows really go? They really go up. I've showed you that whole story before, right? This is the real deal. This is the safe space.
That's the S block, the P block, the D block, and the F block. So let's start with the S block. And the S block includes families 1 and 2, and you have to remember to include helium with that. It's actually part of the S block.
All right, so your left two columns. Choose a color. Lightly color them in, and that's the S block. Because you have the real one. Is the first column 1, 2, 3, 4, 5, 6, 7 down? I think so. Is the second one 6 columns down?
Yes.
I think it's exactly like his on this side, isn't it?
So we just pick a color.
Yeah, anyway, S block up the top. Big S up at the top. Maybe a color you can read. Why is it called the S block? If we did the electron configuration for hydrogen, it would end in a 1s1. Let's go underneath that. I'm going to jump to lithium. If we did lithium, it would end in a 2s1. If we did sodium, it'd end in a, you tell me, 3s1. If we did rubidium, who's in the 1, 2, 3, 4, 5th row down, what would it end in? 5s1. Francium would be a 7s1. Everything in the first column, its last energy level is an S1. And you go, well, big deal. That's what we discovered years later. That's why they all react the way they do. That's why lithium and sodium, potassium, rubidium are super reactors. They're actually dangerous. They're so reactive. They're so reactive. So I like you. You have a big S for this whole column, don't you? I would like you right above the first column to put S1. That's a reminder they all end in an S1. 1s1, 2s1, 3s1, 4s1, 5s1, all the way down. You don't need to write all those in there, but for the whole column, they end in an S1. Questions? This is really advanced. I mean, we start out real slow and easy. We know how to use the green sheet. You're experts on it. Next year, when you go to Mr. Bryant's room, he's not going to give you the green sheet. He's going to give you a periodic table. He's going to point to that one and say, where's this last electron? And you're going to say, 5s1. It's in the 5th row. That's where the 5 came from, isn't it? It's in the S block. And the 1 comes from the column, doesn't it? Hey, we can get this. So what if I said, hey, where does that atom, where's its last electron? Maybe. Somebody take a chance. You're saying, I think it's a 2s2. Why didn't you put the big 2 in front? Second row. Why did you put the 2 superscript? It's in the second column over, isn't it? All right? And you'd be absolutely correct. If I said barium, where's its last electron? Kyle, you're out. Okay, what's the first number in front? 4? Maybe it's a 4s2. Anybody else have a different thought on barium? Dylan, like 4s2? You like a 5s2. Someone else have an idea? You want a 6s2. S2. How about a 7S2? Going for a 7S2. Where does the first number come from, Hannah? The column or the row? The first number comes from the row. Now here's the problem. First row, second row, third row, fourth row, fifth row. We are in the sixth row. But I know what's up. What is so weird is there's nothing in that first up there on that first row, is there? But so it is. The winning answer is it is a 6S2. I would absolutely understand why you'd say a 5, because if you count it down, but you got to start at the very, very top. We're just learning it. First time we did this. We're going to fall off the bicycle a few times, but we're going to end up riding this bicycle and be experts at it here in a few minutes. Questions? What's that? So, if you would, thank you, at the top of the second column, you could write S2. You're right, Kyle. Thank you very much. Everything in here ends in an S2. And they all react very similar. If you look at their endings, beryllium, magnesium, calcium, strontium, barium, radium. They put that same ending on them. What's happening that way? All right, keep going. What's the equator? Oh.
The next block we're going to label is the P block. And that includes everything from family number 13 all the way to family number 18. And in the middle, we're going to have...
We're going to stop right there, P block. Miss Shelley. Is that what you asked me about? Something else. Yeah. Yeah. We need to talk about a couple of oddballs here in a moment. I want you to get that, just color that grid in. That whole grid in. Yep. And why are we, all the way to the bottom, thank you. Why are we not surprised that it is 6 columns wide? Why does that make perfect sense? That's it, looking good. Because the P suborbital will tell the 6 looking good there, looking good, looking good, looking good, looking good. Now, a few oddball things. First of all, see helium? In one sense, helium should really be there. Helium ends in an S2. Helium ends in an S2. Why do we stick it over here, Mr. Mendelvium? Because it, the tape you saw, why did he stick it way over there with these P's?
See how it's blue and it's going down because they're all the same type of thing.
What does everything in the column do alike? Mr. Mendel said they react the same. So helium is an oddball in that it reacts like these other chemicals way over in the right-hand corner. It's ending electrons in an odd spot. Now, on the paper you have, what else appears? Well, shoot, you have another hydrogen right there, don't you? You have you have 2 hydrogens. Why? I don't want to talk about today. That's going to be, we're going to wait, and we may not get to that till January. But in some ways, hydrogen definitely belongs here in the top left corner, definitely. And sometimes it acts like these guys here. And that's all I want to talk about at the moment. Okay. So, let me erase a little bit of this. and ask you a question too. I'm going to pick out boron. Eyes up. Shelby, I'm up here. I'm going to ask you, where is its last electron configuration? Maybe Kyle says it ends in a 2p1. Any other suggestions? Good, because that's correct. Where did the 2 come from, Kyle? It's in the second row. That's where the big 2 came from. Why we put a P? It's in the little P block. And where did 1 come from? It's in the first column of the P block. You first got to get in the block, and it's the starting column of the P block. All right. So if I said Dylan, where's its last electron? Everybody be ready. Okay, if I said Brianna,
4p 4 5.
The D block. And that includes all the transitional elements. And for our last block, no prizes for guessing, this is going to be the F block. Now the next thing we need to do is we need to label down some numbers next to each of the blocks.
all right, here, quit jumping around a little bit, boy. Here's where ours looks different, doesn't it? We have taken our scissors, okay, we have taken our scissors, cut here, cut here, cut here. We have shoved all that way to the right. We have slipped the F block up like it should, and we taped them back together, didn't we? Because you got the real deal. All right, stop. Color in your 2 sections. And how many sections wide will this D block just have to be? How many columns wide does it just have to be, since it's a D? 10. And how many columns wide is the F? How about that?
Let's start with the S block. I'm going to put the number 1 next to hydrogen, number 2 next to lithium, and stop me if you see a pattern here. We go all the way to number 7, francium.
Now you know what that's for, isn't it? That's the 7 energy levels.
And that's going to be
The 7.
next to boron. And
He rewrites them over here in case you get confused. I don't think so.
right on the line.
If you want to write 1, 2, 3, 4, 5, 6, 7, that's fine.
Next to
I
gallium,
really think you guys got it.
5, 6,
I think
and
so.
lastly a 7.
Pretty good.
For the D block, we
Aha!
put a number just to the left of scandium, number
Careful.
3, number 4, number 5, and number 6. And
Now, what is unusual about those 4 numbers?
It starts with 3. Weird.
Uh-oh, it's really, you would say it's in the 1, 2, 3, it's really in the 4th row, which is quite hard. All right, when you get to the D block, you have to go -1. Why? I'm glad you asked that question. I've been disappointed if you didn't ask that question. I need a green sheet in front of me. I don't have a green sheet in front of me. Thank you very much. He's responsible. It has to do with, see how we seem to jump backwards at this point? We go from a 4S back to a 3D, because that's the way atoms do it. That's the way they put them in order. We have to go back 1. We have to go back 1. All right, so You got D block labeled. I suggest after D block you put -1. D block -1. Let's practice. All right. Here we go. Eyes up. Pencils down. I want to take vanadium right here. Vanadium. I said
I have no clue where.
David. Right here's vanadium. V.
No, I'm talking about on our paper.
I'm in the D block. It's over a section. Dylan, don't have your attention.
Yeah, I got it.
Shelby, pencil down. Find V. All right, I want to know, David, where its last electron is. You know I can put the D, can't you? All right, so now the tough question is, what is the number that goes in front? It's a 3D. All right, even though it's the 1, 2, 3, 4th row down, when you get to the D block, take your pencils. Even though it's the 4th row down, this -1 says 4 minus 1, so I got to 3. All right, what superscript, David, would you suggest vanadium's is? Because it's the 1/3 column over. Congratulations. Jalen. Maybe right there. I want to know where its last electron is. What's the easiest part to this? I need number, letter, number.
3 S. Alright, so it would be, wait. 1, 2, 3, 4 D.
Maybe it's a 4D3. That's a possibility. Johnny says maybe it's a 5D7.
Where
That's quite all right. We're working our way to eventually. Will suggests 6D3. Anybody else suggest? Hannah suggests something different. No? Brianna? No? None of them are right? All right. Of the 3 of the number, the letter, and the superscript, which is the one we feel really good about? No, you're not answering my question. The number, the letter, or the superscript? What's the one we feel really good about?
The letter, all 3.
D. We're good about the D, the letter. So here's my suggestion. Get the letter down. Hey, I got 1/3 of it right. I'll get that point, won't I? Okay. Of the 2, the superscript or the number in front, which one do you feel better about? I feel better about the superscript. What do I count? It's in the 7th column in the group. It's a D7. It's a D7. Shelby, please, I'm up here. Thank you. Questions where the 7 comes from. Now, here's the tricky part. Where does the big number in front come from? Superscript was the column. They're called rows. And so far, 1, 2, 3, 4, 5, 6. This is the 6th row if it's a 6S. It's the 6th row if it's a 6P. But if it's a D, I got a -1. 6 minus 1, it's a 5D7. That's hard, isn't it? That's way harder than where we've been. That's way more difficult than where we've been, isn't it? Okay. David, where's its last electrons, please?
For the F block,